Hey everyone, welcome back to another session of STEM Bootcamp for the SAT Math course. Today we're tackling an essential skill for the SAT, solving quadratics by factoring. So factoring is one of the fastest ways to solve quadratic equations, and in this lesson we'll cover, let me activate my pen. Basic factoring, by grouping, special cases that you guys should be familiar with. Okay, so let's start off by talking about what exactly a quadratic equation is. So a quadratic equation is any equation of the form ax squared plus bx plus c equals 0. Okay, where a, b, and c are constants, and the goal of factoring is to break this equation into simpler binomials, making it easier to solve. Okay, so now let's consider factoring when a is equal to 1, or in other words, 1 is our coefficient for x squared. So let's consider factoring when a equals 1, meaning there's no coefficient in front of x. So for example, let's say we have x squared plus 7x plus 10 equals 0. Okay? And the first step 1, is to find two numbers that multiply to c and add to b. Okay, so let's consider what we have for c here. So our c in this case is 10, and what's our b? 7. So what are two numbers that are going to multiply to 10, however, add up to 7? So two numbers that do that, accomplish that goal, is 5 and 2. Okay, so now that we figured out the two numbers that multiply to 10 and add up to 7, we can write our quadratic equation as a product of binomials. So we'll take x plus our first number, and we're going to put a plus right here because it's a positive 5 and a positive 2 that we get for the numbers that work. And we'll put an x plus 2 over here. Okay, and then we can solve for x using the zero product property, right? Which means that x plus 5 equals 0, because let's say this 0, then this by default, this x plus 2 section would also be 0. So we just have to equate either of them to x plus 0. So let's first start with the left binomial, equate that to 0. So once we do that, we solve for x, subtract 5 from both sides, you get x equals -5. Okay, and now the right binomial, we equate that to 0 as well, subtract 2 from both sides, you get x equals -2. Okay, so then your final answers for the solution of this equation after factoring by grouping is just going to be x equals 5 and x equals -2. Now, let's consider a situation when there's a coefficient other than 1 in front of x squared. Okay, so factoring when a is not equal to 1. Factoring by grouping. Okay, so for example, let's say we have 2x squared plus 7x plus 3. So the first step is to multiply a and c, okay? Which in this case, a is 2 and c is 3. And once we do that, 2 times 3, that's going to give 6. So now what we do is that we have to find two numbers that multiply to 6 and add to 7. Okay? And what are two numbers that multiply to 6 and add to 7? Well, 6 and 1. And this set of numbers works because 6 times 1 will give you 6, and 6 plus 1 will give you 7. Okay? So then we have 2x squared, right? And we rewrite the middle term bx, right? We rewrite this middle term using these two numbers. Okay? So 2x squared plus 6x plus x plus 3. And notice, if you were to take these two middle terms right here, for where you have the x to the 1 power, right? 6x plus x is going to add up to give you 7x when you combine like terms. Okay? So now that we've done that, we group the first two terms and the last two terms. So then we have 2x squared plus 6x plus 1x plus 3. And then let's factor out common factors in each group. So if we look at this group right here, what common factor can we take out of 2x squared plus 6x? Well, we can factor out a 2x, right? Because then we'll get 2x times x, because 2x squared divided by 2x is just going to give you x, and then 6x divided by 2x is just 3. And plus, and over here, we can just factor out a 1, right? And the reason is because we have an x plus 3 here, and we have an x plus 3 here. Okay? Now, if we look at these two terms, right, what we could do, because this is one whole expression right here, this is another expression right here, we could factor out x plus 3 from both of these terms. Okay? And once you do that, you'll get x plus 3 times 2x here, and then you'll get you'll get x plus 3 times 2x plus 1. Okay? And this should intuitively make sense, because if you were to distribute this entire x plus 3 expression with 2x and 1, you would then get this expression right here. Okay? So then now that we have our quadratic form simplified to x plus 3 and 2x plus 1 equals 0, we can set both of them equal to 0, x plus 3 equals to 0, 2x plus 1 equal to 0, and solve for solve for x, for each case. So subtract 3 over here, you get x equals negative 3, subtract 1 over here, you get 2x equals -1, divide both sides by 2, you get x equals -1 over 2. So then your solutions are just going to be x equals -3 and x equals -1/2. So that's how you'd factor when you'd have a constant for x squared that isn't 1. Okay? So remember, take your A, take your C, multiply them together, and once you get that product, which is 6, find two numbers that multiply to 6 and add up, but add up to your binomial term over here, and then you go from there by taking out the greatest common factor for the first two terms and the last two terms, and keep going, so on and so forth. Okay? All right. Now, let's consider some special cases. Okay? So let's say, for example, we have 3x squared plus 12x equals 0. Well, notice that right off the bat, we can already take out the greatest common factor from this expression right here, right? And if we consider this expression 3x squared plus 12x, what's the greatest common factor that we can take out of this expression? I'll give y'all a minute to think about it. Okay, so I'm assuming you guys attempted to find that out, but if you were to look at this expression, you'd realize, okay, we can take out a 3x, right, which is the greatest common factor from this expression right here. And once you do that, you divide 3x squared plus 12x divided by 3x, you get 3x times 3x squared divided by 3x is just going to be x, and 12x divided by 3x is just going to be 4 equal to 0. So then you can set both of these expressions equal to 0 and solve for x. So 3x equals 0, x you get 0, x plus 4 equals 0, x you'll get -4. So then your answers for this case is going to be x equals 0 and x equals -4. Okay? Now, let's consider an important rule that you'll come across on your test, which is the difference of squares. And it's very important to keep this formula memorized. Okay? And some quadratics can be factored using a special shortcut with the difference of squares formula. Okay, so if you have a squared minus b squared, that's going to be the same thing as a minus b times a plus b. Okay, so for example, let's say we have x squared minus 16. Okay, well, what's the a going to be in this case, given this expression? Well, our a is just going to be 1, right? And what's our b going to be in this expression? Well, our b is just going to be, a is not going to be 1, a is going to be x. Let me rewrite that. Let me erase that here. Because when you square a, or x in this case, you're going to get x squared. And when you square b equals 4, you're going to get 16. Okay? So now this expression is just going to become x minus b, which in this case we've defined a to be x, right? Minus b, which we've defined b to be 4, times x plus 4. Okay? So then if we want to find our final answer, we set x minus 4 equal to 0, x plus 4 equal to 0. So x is going to become plus 4 for here, and x will be equal to -4 for this solution. So then your two solutions for this scenario is going to be x equals 4 and x equals to -4. Okay, so some important tips to keep in mind when you encounter these types of questions is, first, always check for the greatest common factor. All right, and if a is not equal to 1, factor by grouping. And plug answers back into the original equation if you want to check for mistakes. Okay, well, that's a wrap on solving quadratics by factoring. We covered basic factoring, factoring by grouping, and special cases like the difference of squares. Make sure to practice these types of questions so that it will become second nature in regards to how to factor. With that said, y'all, have a good one, and I'll see y'all in the next lecture. Bye-bye.